Hello everyone. In this video we are going to look at a problem based on synthesis of ethers. So the question that is asked here is, Williamson synthesis is not a suitable method for preparation of certain type of ethers, and we need to substantiate this statement with an example. The second statement states that preparation of ethers via acid dehydration of secondary or tertiary alcohol is again not a suitable method for the synthesis of ethers. So we need to justify these two statements with suitable reactions. Let's try to solve this question. So as you know, Williamson synthesis or this method is a very good method for the synthesis of symmetrical as well as unsymmetrical ethers, and especially when we need secondary and tertiary alkyl groups in our ethers. So as you can see, it is a reaction in which alkyl halide reacts with sodium alkoxide to give corresponding ethers as shown in the reaction here. However, this method is not suitable for certain reactions. For example, reaction between tert-butyl bromide and sodium methoxide does not give us an ether as is expected, but results in the formation of an alkene. As you can see in this reaction, here we have tert-butyl bromide and sodium methoxide. However, instead of having a nucleophilic attack on this particular alkyl halide and eliminating Br, we essentially end up getting an alkene where methoxidine abstracts a hydrogen atom and gives us an elimination reaction. So this is mainly because, as you can see, our alkyl halide is a tertiary alkyl halide which is highly sterically hindered. And we know methoxidine is not only a very strong nucleophile but is also a very good base. So what it does is that it cannot attack the CBr bond to result in a nucleophilic substitution reaction, as our alkyl halide is sterically hindered, and hence it prefers to abstract the hydrogen, resulting in an elimination reaction giving us an alkene. However, you can also note that by simply modifying this reaction, we can obtain ethers as well. For example, by having a substrate which is a primary alkyl halide. So as you can see, here we have a tert-butoxide alkoxide and it is reacting with primary alkyl halide which is methyl iodide. So as you can see, the oxygen atom attacks this carbon and iodide ion leaves, giving us corresponding ether as shown here. This is again a Williamson synthesis where we have modified the substrate so as to obtain an ether. So as you can see, this reaction takes place because we have a primary alkyl halide which is sterically not hindered. Let's now go to the second reaction, which states that acid dehydration of secondary and tertiary alcohol is not a good method for the synthesis of ethers. Here you have an example which is a secondary alcohol, and which on protonation you get the oxygen atom which gets protonated, and with the elimination of water molecule, here you can see that here we have a secondary carbocation. You can also note that due to the steric crowding in secondary and tertiary alcohol, and also due to the size of the approaching nucleophile, these carbocations generally prefer to undergo elimination by abstracting a hydrogen ion. So as you can see in this reaction, here we have CH3, CH plus CH3. As you can see here, instead of this carbocation undergoing a nucleophilic substitution reaction, it undergoes an elimination reaction where H plus ion is abstracted and gives us corresponding alkene. So this is why secondary and tertiary alcohols, due to its tendency to undergo elimination, that is why this is not a preferred method for the synthesis of ethers. I hope you are very clear on how we have arrived at these two solutions. Thank you.